We're now going to look at the conic section called an ellipse. Let's look at a definition. An ellipse is the collection of points in the plane, the sum of whose distances from two fixed points, called the foci, is a constant. So the distance from F1 to P plus the distance from P to F2 is some constant value. In fact, that constant value is equal to 2 times A, where A is the distance from the center to V1. If we work through the proof, we can get the formula for an equation of ellipse. The equation that we're going to give right now is the equation of an ellipse whose center is at the origin and the foci are at plus or minus c, 0, so that the major axis is along the x-axis. An equation of the ellipse with center at the origin and foci at negative c, 0 and c, 0 is x squared over a squared plus y squared over b squared equals 1. A must be greater than b, which must be greater than 0. And finally, b squared equals a squared minus c squared. Again, the major axis is the x-axis, and the vertices are at negative a, 0 and a, 0. Let's go ahead and look at an example where we are given certain information about an ellipse and are asked to find the equation of the ellipse and then graph it. We're given that the center of the ellipse is at the origin. We're given that the focus is at 3, 0 and a vertex is at negative 4, 0. If we just picture in our mind what we have here, or literally go ahead and graph these points, we can see what we're dealing with. I have a focus here on the x-axis, and I have a vertex over here on the x-axis. What that means, because the vertex and focus lie on the x-axis, the major axis is the x-axis. So we're going to have an ellipse whose equation is of the form x squared over a squared plus y squared over b squared equals 1. A is the distance from the center of the ellipse to the vertex. From the center to the vertex is 4 units. So I have that A is equal to 4. C is the distance from the center of the ellipse to a focus. The distance from this center to the focus is 3 units, so I have that C is equal to 3. I can find the value of B by recognizing that B squared is equal to A squared minus C squared. Therefore, B squared is equal to 4 squared, or 16, minus C 3 squared, or 9. 16 minus 9 is equal to 7. So B squared is equal to 7. Therefore, the equation of the ellipse is x squared over a squared, which is 16, plus y squared over b squared, which is 7, equals 1. Now what we're going to do is graph the ellipse. I graph the ellipse by labeling, first off, the vertices. I know that I have a vertex at negative 4, 0, which is 4 units to the left of the center. Therefore, I have a vertex at positive 4, 0, which is 4 units to the right of the center. I have my foci that are 3 units to the left and to the right of the center. And finally, what I need to do is figure out a way to find points on the vertical axis. Remember, what I'm doing here is graphing x squared over 16 plus y squared over 7 equals 1. If I let x equal 0 in this equation, what am I going to get? I'm going to get y squared over 7 equals 1, which means y squared equals 7, which means that y is plus or minus the square root of 7. So I have a point here at positive square root of 7 on the y-axis, and a point down here at negative square root of 7 on the negative y-axis. I use these points to draw in the graph of the ellipse. Now bear in mind that I am no Van Gogh, so this graph might not look very good to you, but we'll do the best that we can. So here's what we have. This point here is 0, comma, square root of 7. This point down here is 0, comma, negative square root of 7. In general, these points will be 0, comma, b and 0, comma, negative b.